Hello, everybody. Um, Welcome to the webinar. Today, we're going to talk about null references, null pointers, basically null references in object-oriented programming. And my main message today will be I will try to convince you that null references is something really bad in object-oriented programming, and this is something that has to be avoided at all costs. So we're not going to discuss when it's like good to use null references, when it's not good to use them, but instead I will try to convince you that in general, the presence of null references in object-oriented programming is something which is terribly bad and terribly wrong and a bad practice. But first of all, let me show you what the null reference is, just to introduce you to the problem. And let me share the screen with you. Here's the piece of code. And this is a simple method in an object, which, as you see, is trying to get and it accepts the name of an employee, and it's trying to find the ID of this employee in the database. And if it's a primitive example, but if the ID is equals to 0, then the method returns null instead of an employee. And if actually the ID, or maybe you can do it like this, if it's less than 0, for example, it's like an indicator of the database didn't find anything, and then returns null. And in another case, in a success, like something was found in the database, it actually returns the actual instance of an employee. So here is, I'm sure you've seen this in many software, in many places in your software or open source software. Like, people use it everywhere, and this is what is considered to be wrong, and specifically this line is wrong. So instead of returning an instance of employee, we return null, which is not an object, which is some specific thing in OOP, and it exists in like many object-oriented languages, and I'm trying to argue that that shouldn't be used. So I'm not the only one who is saying that. There are many like articles and presentations and articles and some blog posts about that. And the main thing what people are saying about that, why it's wrong or why it may be considered wrong, is that the main argument about that is that it may cause many exceptions, null pointer exceptions in the code which is actually using this function. Let's take a look at this. For example, I'm doing get by name, and then I give the name, and then I'm trying to get the salary of the person. So in this case, if the object is not found here, if there's actually no employee by the name Jeffrey in the database, then I will have the null pointer exception over here. So it's not going to be a message to me. So I will get the stack trace, which will contain some kind of strange technical information saying there is null pointer exception, the object is null. Instead of an object, we have the null, and we cannot call the method salary. So that exception will, in this small example, it will be more or less clear for me that why this null pointer exception is happening. But if the code gets bigger and bigger, then eventually this null pointer exceptions, they will happen everywhere occasionally, and will be rather difficult to understand where they're coming from and what's going on. So the main argument against this null references is that it will be technically difficult to trace the problems, because this null pointer exceptions may happen somewhere in some places of code, and it will be difficult to trace the causes. That's the main reason. And also, like, people saying that that actually this null reference is coming from let me turn it on. So the null pointers, they're coming from actual like procedural programming, or even like old C programming, where actually the people were dealing with pointers. This is not what we have in modern languages like Java, Ruby, or Scala, for example. We don't deal with pointers directly. We work with objects. But this null was introduced in the languages which were using pointers, and the pointer is actually the location of some object in memory, and the pointer just a few bytes which are saying where I can find the object and what's the address of this object. So the null was actually a 0, like all of these like bytes, for example, 4 bytes or 8 bytes, which are supposed to contain the location of the object. They contain zeros everywhere, which is supposed to be an indicator for the user of this pointer that actually there is nothing in there. So don't go there, don't go to this memory place, and don't try to find anything there, because there's just zeros everywhere, and it means that the pointer you have is actually not a pointer, but a placeholder for a pointer. So you, as a client of this, or the user of this pointer, you're supposed to know that zeros means something different from normal numbers. And so it's always your problem to how to understand, how to interpret the pointer I give it to you. So you ask me for the location of this employee, for example, and I give you the pointer, and you should know that if I give you zeros, then there's no employee. Don't go there. Don't look at this memory address by these zeros, because there's nothing in there. But people sometimes forget about that. They just don't check for these zeros, and they just go to this memory and they check what's there, and they get an exception. They get exception. They get some software crashes, and a lot of malware and a lot of like viruses. They were designed like old viruses, like the viruses we get like a long time ago. They were designed basically, you know, they were relying on this fact that some software forget to check the pointers, and they can eventually go somewhere where there's nothing in there. So this whole situation with managing pointers and using zero pointers, that kind of, you know, caused the many technical problems. This is what the arguments are against this null references, and like arguing for people, asking people not to use them. But this is not what I'm going to say today. This is not my main point. But let me give you a few alternatives before I give you my arguments. So basically, there are a number of, I know, 3 possible alternatives to using null pointers, to using null references when you can't actually find the employee. So when you are looking at when you're looking into the database and you actually can't find anybody there, so what can you do? The first option is, instead of returning null, the first option is return so-called null object. Well, actually, the first option is throw an exception. That's going to be the first option. So I can throw a new employee not found exception. And then I can say here something like, you know, I'm sorry, but the employee is not found. Something like this. So in this case, if the client is getting the same as we were doing before, and he's trying to, the client of mine, he's trying to get the salary, then the exception he will get here, actually. So he will not even go to the salary. The failure will happen here, and the exception will be raised. And the whole situation, the whole software, which is like trying to do something with this employee and do something and print the salary and change the salary, the whole software will crash, and the user has to do something about it. That's the first approach. The second one is to return an so-called null object. For example, let's say new employee, let's say no employee. So this class implements the employee interface, but it implements it not the way, let's say the employee is the interface and we have real employee here and there is no employee here. So there are two classes which actually implement the interface employee, but they do it differently. This one actually implements it the right way and makes sure that this employee has the salary and knows what to do with the salary, and it's actually a real class. This is a null object which doesn't know, which behaves differently, which behaves like the employee is not found. So in this case, let's say I just get the name Jeffrey and I don't ask for the salary. I just get the object by the Jeffrey, and then I exit the software. So that's the end of the execution. In this case, there's no failure here because I got some object, I got some Jeffrey, but there's no Jeffrey. But I don't care because I don't need to do anything with Jeffrey. I just exit the software. I just exit the application and I stop. So that's the null reference, the different approach. And also there is also one approach which is kind of, quite, popular now and fresh, is to so-called optional object. For example, I can say here I return optional, which is empty, and here I return optional, which contains something. So optional is kind of a container with 1 or 0 elements. So in this case, if I return get by name Jeffrey, I don't get the Jeffrey directly. I am saying something like this: optional. It's in Java, but in other language they have something similar. So it's an opt, and then I'm saying if has something, then I can actually get the salary. Opt get, and then I get the salary. So, and if there is nothing there, for example, if actually the Jeffrey was not found, then I do something, I don't know, I print something like, sorry. So these are the 3 options I'm aware of. Maybe there are maybe there are more, but I cannot even imagine what could be besides that. So the first option is throw an exception. The second option is to use the null object, which looks like an object, which looks like a normal object but behaves differently. And the option number 3 is return some kind of a holder, a container of 0 or 1 object. I honestly think that the option number 3, this one, is wrong. So it's not a solution for a null reference. But the first 2 options, the exception and null object, is the perfect solution. So the problem exists, like I explained, and the solutions exist. But my main argument, my main reason against this thing is not about technical stuff. It's more about theoretical approach to object-oriented design. I think that null reference is something that violates the entire idea of encapsulation, and it breaks and actually destroys the trust to the objects we're working with, and it causes it's like a disease in the entire application, which if we allow it to enter our software, then it will actually grow and eventually will how do you call it, will infect the entire code. So the problem, I think, that there's null references. They are telling me that I should not trust my objects. That's what's happening. So when I get an object, when I get an employee from this function, and I'm expecting this employee to be an object, then I'm expecting it to be something which completely encapsulates what's inside, and I can ask this thing to do something for me, and this thing is supposed to return me something back. It can throw an exception, it can behave differently, it can crash, it can do whatever, but it's a solid thing which I trust. So I know that there are borders of the thing, it encapsulates what's inside, but I trust that this is an object. So I when I build my software, I deal with many different objects, and I trust all of them. So I know, by using the word trust, I mean that I can rely on them to be self-sufficient. I can rely on them that they will be objects for me. So they will look like objects and they will behave like objects. When I'm getting something which is not an object, then my entire thinking is changed. I start to think differently. I start to suspect all of my objects, all of the variables which I'm using, all of the things which I'm working with. I'm starting to suspect that they're not good enough, that they're not objects anymore. They can be something else. I'm getting an employee, but I suspect, like, hey, maybe it's not an employee anymore. Maybe it's something else. Maybe it's null, which is gonna crash when I just start to touch it. But it's not going to crash because there's some logic inside it, because it decides so. But it's going to crash on my way to it. So basically, it breaks. It makes me it makes me think that the stuff I'm working with, the object, the elements, the items I'm dealing with, they are not real objects. They're not following the contracts I'm expecting. They are not any more object. It's similar to scalar types in Java, for example. In Ruby we don't have that, but in Java we still have an object, which is an employee, for example, and still we have, for example, a salary of this object, which can be a number, like an integer number, which is just a number, just a scalar type. It's not an object. I cannot call any methods on it. It's something which is different from an object. So in Java we have like two types of citizens. We have objects and we have scalar types. This long, double, float, integer, Boolean. So there are two different kinds of citizens. And also we have the null. The null is the thing, the creature number 3 of a type number 3, which is kind of messy situation, and it leads, like I said, it leads to the situation where I, as a developer, losing the trust in the items I'm dealing with. So instead of building the software and relying on these elements, I have to always check what do I have. Because in case of numbers, the problem was solved in Java because there's automatic boxing and unboxing. So when you return to me the salary of the employee, and that this salary is actually a number, so an integer, then I'm trying to use it as an object, then it's going to be like some kind of boxing will happen, and the Java will automatically convert it to an object type integer with a capital I. But in case of null, it's not happening. So in case of null, I always have to check what's there. What did you return to me? Did you give me back the proper employee, or you gave me back the null? And because of this distrust, because of this dualistic situation, like I always have to remember which way to go. I always have to distrust you as a provider of objects for me. I have to be careful, and these extra checks and extra validations will eventually, like a disease, like an infection, will cover the entire application, because I will have to check it everywhere. My distrust, my kind of what do you call it? Just the attitude towards these items I'm dealing with will eventually be spread across the entire code. And my functions, they will get longer and longer. So instead of just getting an object and asking the salary and using the salary, I will have to get an object, check whether it's null or not, and then do something, and then get the salary. And then in a bigger function, which is bigger than that, I have to remember that the salary is also maybe null, maybe not null. So this if null or if not null will be everywhere. And this is completely against the object thinking, against the object-oriented, mentality and paradigm. That's kind of my point. And so the technical issues, which like the main argument, I don't think it's really that strong, because if you just go to the technical level and say, this is what I actually got on the blog post I made like a few months ago, the main point people were expressing in the comments, they were saying that what's the difference actually between getting the null object and getting the null as a null? You still have to sometimes to check whether it's an object, whether it's a null. So it's like technically it looks very similar, this if, then, else comparisons. And on the technical level, I agree with this counter arguments. People saying that it's just sometimes more convenient to use null, and it's nothing kind of wrong with using null sometimes, because it's just the stuff we're used to. And even if we replace it with the null objects or exceptions, it's kind of not going to change a lot in the code. I agree with that, but it changes a lot on a bigger scale. It changes a lot if we look at the attitude we have to the code we write. Because if we start to get used to null, and we all are, we have, like, look at the open source stuff we have around us. everybody is using this null references. Everybody is using this approaches, and we're kind of used to that. We just know that we have to expect null. Look at the Java standard classes and libraries. Many of them are just document the situation. They just say we're going to return you the list of files, for example, in the folder, or you get the null if there is no files and there is no folder. So it's like a standard situation, which Java itself encourages us to use, encourages us to think that way. And I get this counter argument of people saying that, what's the point? Why do we need to get rid of this null? Because it's so technically convenient. It is technically convenient sometimes, but conceptually and like theoretically, conceptually, it's something which is going to destroy your design and architecture of the application if you let it happen in your code. So it will eventually, it will affect the way you think, and the way you think will affect your software. So if you think about objects and nulls, then you're not thinking about OOP anymore. You're not in object thinking anymore. You're thinking like that design, like the C programmer 20 years ago. Like this is the pointer, and the pointer may be zeros because there is nothing in memory. But in object thinking, you don't think about memory and pointers. You think about objects which are kind of like living organisms for you, like something which is like some living creatures which are not necessarily located in memory. You don't think about memory anymore. You think about objects and calls to them and messages to them and their reaction to you. But null doesn't have any reaction. It's not an object. It's something which is from completely different class, from completely different world. It's not from object-oriented world. It's from procedural 20 years ago type of thinking and programming. So that's my kind of argument. So it's not about technical things. Technically, null has nothing wrong, I think, in just using it here and there sometimes. But conceptually, it's very wrong. And so that's what I wanted to say. And here is like, kind of would love to hear your questions, but before you post your, you can start posting your questions. But I have like a few questions which were asked on the blog, and I want to answer them. Like some of them are quite interesting. The first question is that people are saying that some classes, that's the question I got. Some classes are in Java, for example, they are just not suitable for making null objects. For example, the string class, it's final. So the string in Java is just a final class. It's not an interface. So when the method is supposed to return a string, then there's no option to return a null string or null reference. You just have to return string or something else. So there has to be some other option you return. In this case, that's kind of a valid concern, and it's a big flaw in Java design. It's a defect we have in Java, like in entire language design. So they made, for some reasons, they made some objects final, some classes final, and there is no way to extend there's no way to actually use them in a proper object-oriented way. So this is just, very solid structures which are final, which are not supposed to be extended, which are not supposed to be re-implemented by somebody else. So it's just, my answer here is that it's just the misfortune of what we have. And we just, sometimes if you really want to do your design right, sometimes you may need to re-implement some of the really fundamental basic Java or your language constructs. For example, if you need, in this case, if you need a function which will return a name, for example, of an employee, and in some cases there is like no name of an employee, and you still want to be able to return something, and it has to be like string, like a text, then introduce your own interface, your own class, and call it text. And then you will have the normal text, and then you will have the null text, which will actually decorate and wrap the string thing, the string class in Java. So my answer here is that Java is not perfect. Java is not the object-oriented, not a pure object-oriented language. It does have many flaws and many defects in terms of object thinking. So it wasn't designed as a language for pure object software, and that's why they have this problem. So, but it doesn't mean that we should stop thinking. That we should make compromises, and that we should develop the software in the way Java tells us to do that. Java is just an instrument which helps us to put our thinking into to help us to convert the way we think to the way computers can run. The Java is just an instrument which helps us to translate our object thinking into the way computer can understand it. If Java is not a perfect it's not a perfect translator, and it is not the perfect translator, then let's just change it. Let's just improve it. But let's not, change our thinking to the way translator can understand it, because that will only, do some, bad things for us, because our thinking will be affected by the way people thought 20 years ago when they invented Java, and their thinking was kind of wrong in many places. So we should think in a right way, and then just adapt Java for us, not us for Java. That's what I'm saying, and it's possible. Java is quite flexible language, as well as other languages like Ruby or Scala, or like popular object languages. So here's my answer: that yes, sometimes it's not possible to use null objects everywhere, but if it's not possible, let's make it possible. But don't make compromises, and never use null. That's the point. Never, ever. So if you see it in your code, this is like an indicator that you're doing it wrong. That's it. There's no gray area. There's just black and white. That's my point. So if you use null, the code is wrong. It needs to be refactored. It needs to be changed. Even though the Java is actually not encouraging you in this particular place to not use the null. You have to be stronger than Java. That's my point. Another question is also quite interesting, but it kind of resonates with the things I said before. People are saying that null is fast and exception is slow. So when I return null, it's just and then I let my client to check it. It's much faster than throwing an exception and letting my client catch the exception and do something about it. So if, for example, in example with the employee, let me show you the code again. Here. So if so here's the code, and I throw here an exception. I say no employee found exception, for example. And then if it's found, I return a real employee. And here's the client. So the client, in order to deal with this stuff, it has to do something like that. It has to get by name Jeffrey, and then it has to catch that exception. And then do something about it. For example, I don't know, print. This is one code. And that's another code. If I would be returning null, the code would look completely different. I would say something like this. I would write it like this: if Jeff and otherwise there, get by name, and then I do, I don't know. So I have, and I'm saying Jeff, sure you follow. So definitely, obviously, the code here is way faster than the code here. It is faster because every time we throw an exception here, every exception thrown by Java or any other language actually takes a lot of effort for the runtime machine to collect some information about what was the cause of the exception, where it was thrown, to build a stack trace, to prepare this information, to stop the execution, the normal flow, to go to the exceptional flow, and just to print the text. So all we do here is just print the text. So we do a lot of work. We ask our computer to do a lot of work to catch this exception, to throw it here, to catch it here, and then just print one line. Here it's way faster. So we just say, if it's null, it's really fast comparison of the pointer. Exactly, this is the pointer, because this comparison will actually go deeper into the implementation of this object and see whether it's not a real object or it's a pointer, which is a null. And then we'll print something. Otherwise, it will use it as a celery. So technically, definitely, this is faster. The second example is faster. But like I said before, the speed of execution, the speed of the performance of the software is way less important characteristic of a modern software than the maintainability of it. So I'm 100% sure that I'm right here. So no matter how fast is your software, how really high performance it is, the most important thing is how maintainable it is. By maintainability, I mean how easy it is for me as somebody who never saw your software to actually look at it and understand what it does and make changes to it. So the longer it takes for me to actually let me stop that. So the longer it takes for me as a developer to actually understand what your software does and to go through all your logic, the longer this time is, the less maintainable your software is. And maintainability is way more important than performance. So like in this example, so yes, using null in some cases, in most cases, is way faster than using exceptions. But it will make the life of computer easy, but it will make my life more complex, more difficult. So as a developer, I will have more problem to understand your software and more problem to maintain it, even though it's faster for the computer. So the problem with the computer we can solve, we can buy a new computer with just a few $100s, maybe a few $1,000s if it's a really big performance problem. But we cannot buy a new programmer, or we cannot just, we cannot solve my maintainability issues with a few $100s. I cannot write the software faster. It's not a problem of a few $100s. Now it's a problem of tens of thousands of dollars if your software is not maintainable. And programmers, new programmers, or even you in a few months cannot understand how it's written. I'm sure it's obvious. So this using null is, like I said, it's the problem which will, it's the attitude which will eventually penetrate and eventually infect the entire code. It will happen everywhere. If you start using it in one place, you will use it in another place, you will use it here, there, everywhere, and eventually the entire thinking of your software will be null based. So you will be based on the assumption that every object may be a null, and you will check for null everywhere, or you will have null pointer exceptions, and you will have, eventually you will have the code which would look like C code, which will look like procedural code instead of object-oriented. So again, my answer here is yes, exceptions are slower, and yes, nulls are faster, but this is not the argument against, this is not the argument in favor of using null. Especially now, maybe 25 years ago, that was an argument where programmers were way cheaper and computers were way more expensive. In that case, for every millisecond, people were fighting and they were trying to make their software extremely fast. Now it's not the case. Maybe in mobile applications, in like Android or iOS apps, the performance is still an issue, but it's gonna be, it just give it another few years and this problem will go away. So the performance is less important. And when the software is highly maintainable and clear and easy to understand for developers, it will be easier to solve performance problems as well. So that's my answer to this question. I'm ready for your questions if you have any. So you have this Q&A section. We're already half an hour talking, so we have like less than half an hour left. So give me your questions. I'll try to answer them. Another thing which was mentioned on the blog is like one guy said that you know what, this returning null is something that we are used to, and we're comfortable with that. We are like doing this for years, and this is something which we all understand it. That was the point. So why changing now the direction? Why changing this approach now if for many years everybody understand how it works and everybody like are comfortable with the assumption that that whatever comes out of a method can be an object or can be something which is not an object but instead a null. So why should we? I mean, why do we need to change this attitude and this approach if it's so clear for everybody? If it's like, you know, it's like it's we're used to that. That's the question. And my answer here is that it's definitely true. It's definitely true that in many languages we have this null. In Ruby we have the nil. In Ruby we even have the function called nil with a question mark, which you can apply to whatever comes out of whatever, and this function will say is it null or not null. So they actually embedded this stuff into language as well, the designers of Ruby, and it's like so convenient, and everybody just kind of like it and understand it. My answer here is that that's true, but it's more like sad than good. So this is definitely what we have. This is definitely the mentality of programmers we have now, and it only tells us that is that the pure object thinking and pure object-oriented like mentality is something which is not yet incorporated into modern languages, I think. And whether it's good, I think it's bad, and I think it's sad, because this is the reality we have now, and I believe that it's going to be changed in some time. So we have to change it, because I think they're kind of now we have kind of a transition from procedural programming 10 years ago, which was fast, easy to understand when you write it, very close to the way computers think, and not really, you don't really need a lot of knowledge, the fundamental knowledge and principles to write the procedural code. You can teach somebody to write a procedure in a few hours, and just somebody who doesn't know programming at all will be able to write this code. So procedural programming is the very easy translator of your thinking to computer thinking. So you just think, okay, I want you as a computer, you just kind of my worker, and I want you to get this number and add another number to it and give me the result. So I give like specific instructions to the computer, and the computer gives me the result. This is the way procedural programming works. But object thinking is different, and it's more like it makes the distance between the execution platform and the domain area is bigger. So the distance is bigger. We're not staying so close to computers anymore. We are way more abstract now. But the languages we have, they are like 20 years old when it was important and it was more convenient to stay closer to the computer, the execution platform. So we're still kind of having, the computers are far from us now. They're like somewhere in the cloud, and they're so big and so huge. So we don't need to stay so close to them. But the languages, they encourage us to stay close. And that's what's going to happen in the future, I think, in the nearest future. So we don't need these languages anymore. We need languages which are helping us to think our way, to think the way we think about reality, instead of being us programmers, actually engineers who instruct computers what to do. So my answer is that yes, we're used to think in the way computers think, but we need to change that. Why don't you? Yeah. So now we have some questions from you guys. So the question number one is, why don't you recommend the optional approach? Yeah, I kind of was expecting that question. Like I said, there are three approaches. The first one is like, instead of null, the first one is throw exception. The second one is like make some null object, and the number three is optional approach. The optional means the container which we create, and inside the container we package something or we package nothing, and then I give it to you back. I think this is against object thinking at all, as well as null reference. It's a little bit, it's not even better than null reference, because what is this container? What is this? It's a pure data structure which encapsulates the object. So this container is not an object by itself. It doesn't look like an object. It doesn't work like an object. It's like a temporary memory structure which holds a real object. So when I'm asking you, give me the employee, and the name of the employee is Jeffrey, and I'm expecting you to give me the employee. I don't expect any container. I don't expect, I want to get an employee. I want to get an object which I can talk to. But instead, you're giving me something which I need to manipulate with before I can actually work with the real Jeffrey. So this manipulation with this container is actually the trouble you're placing on my shoulders. So you are giving me something which is not yet ready to work with. You're giving me something which I need to think, like how to manipulate with this stuff, how to understand it. It's very close to null references, very close. The same in case of null, you're returning me something, but I need to remember that I need to deal with it somehow. The same here, I need to check, do you have the employee for me or you don't have the employee? So it's kind of it's a solution which is introduced like a replacement for the null reference, but it actually is not. It's not replacement, it just looks like replacement. Because in a pure object world, in a pure object thinking, we're only talking between real objects which represent the real life entities. And they are like people. They're like living creatures. They talk to each other. In the real world, we don't have containers which contain this Jeffrey, for example. I'm not like calling a department and saying, hey, I want to talk to Jeffrey. And instead of putting the Jeffrey on the phone and letting me talk to the Jeffrey, they give me some container which I'm supposed to dig into this container and get some Jeffrey out of it and then talk to Jeffrey. So it's counterintuitive. This is not how we should think if we're talking about objects. So it's just a solution which is not a solution. That's my understanding. Again, on theoretical level. On a practical level, yes, it works. It's perfectly fine. You get this optional. It's introduced in Java 7. You get this optional. It looks like something which is not null anymore, but it's not a solution. It's just a primitive approach to solving the fundamental problem. That's what I think. The next one. Do you have a null object for each domain entity in your systems? In some cases, yes, we do that. In some cases, we design it that way. I mean, me and people who work with me, but it's only where it's necessary, because not every object may have a null. Not every domain entity, like you call it, may have this null thing. For example, in case of employee, maybe it's not even a good idea to return actually the null employee if the Jeffrey is not found. Maybe in this case, I would better throw an exception. But for example, if we, so I would say, to answer this specific question, I would say that rarely. For domain entities, I would create null objects in very rare cases. Mostly these null objects, they are good for system entities, not domain entities, not like employee, department, car, I don't know, vehicle, or I don't know, something else, but something which is inside the system object, like identity, file, directory, that kind of stuff. In this case, these null references are very convenient. That's my answer. Another question is, what should be returned by no employee method? Get salary or get name, empty string, or no employee, or something else? Yeah, I understand the question. So this, for example, no employee is a null object which looks like an employee. So it has the salary, name, and all the other methods which you can call. But the question is, what happens when I call this method? It depends on the situation. It depends. For example, in case of it depends on how you see who is this no employee. For example, let's say I'm calling the department and asking for Jeffrey. Like, give me the Jeffrey on the phone. Like, I want to get this object, and I want to say So the salary is something which definitely can't exist if it's a no employee object. But for example, let me think what can actually exist in that thing. Let's say, okay, let's say the department. So I'm calling I have a department object, and I'm saying in this department object, I have the method which is called like find employee. So I know the department, it's a software development department, and I'm saying give me the Jeffrey, and there is no Jeffrey there. So it returns me the object which is no employee, and it's like it's not a Jeffrey, it's something else, but it's returned from the department software development. So in this object, I may have a method which is called department. So I want to get back the department. And this method is it can be perfectly fine implemented, because even though it's a no employee, I can still get back to the department. I can still get back an instance of a department which returned me the object. So this method is perfectly implemented. But the method salary will throw an exception. The salary method will throw an exception and say, hey, I cannot tell you my salary because I'm no employee. There is no salary here, or there is no name here. But when this happens, the exception which you will get will have a proper explanation of what happened. The exception will say, you know what, you asked for Jeffrey employee, but we didn't find anything, and now you're asking for the salary. This is wrong. That's what's going to be the text of the exception. It's not going to be null pointer exception, boom. And then you need to dig into your code and find out where it happened. Well, it will be a properly formatted exception, which will say, like I said, you were looking for Jeffrey employee in the software development department. We didn't find anybody, but now you're asking for the salary. So getting this exception will actually help you to understand what's going on and how to solve the problem. So to answer your question, what's going to be the results of these methods? They are, in most cases, they will throw exceptions. In most cases, going to be exceptions. So again, I can hear you thinking about like what's the difference, the null pointer exception or this exception thrown by these methods. But there is a difference. Again, there is a difference because the null pointer exception is thrown by the machine, by the Java machine, not our objects, but something which is around our objects, something which we don't control. But the exceptions I'm suggesting, they are thrown by us, by our objects. So we are in charge, we control, we encapsulate this behavior. The objects, they know what to do. They control it, not the machine, not the Java machine, not the runtime's, runtime environment, but specifically my objects created by myself, and the exceptions will have my tags, which I define there, which is very important. That's the difference. So yes, the exceptions in both cases, but the difference is like conceptual. The next question. Doesn't null object just delays the failure? If I want to raise the salary of employee, set new salary, blah, 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 where employee is null object, how should it behave? Definitely yes. Of course. The question is, doesn't null object just delays the failure? Yes, the null object just delays the failure technically. If you're talking about like technicality, like what's happening on the level of of this bits and bytes, then yes, of course, we just delay the moment when the exception will be thrown, and we control this process. We control this moment of throwing the exception. It's not happening accidentally because I gave you something which doesn't work, which I gave you some broken thing, which is completely against your expectations, but the exception is happening when this perfectly organized and proper object is actually decides to throw an exception. So if you want to raise the salary of an employee, which is the null employee, and then you set the new salary, then it should definitely tell you that, you know what, it's not a real employee. You are looking for an employee. I gave you something, but it's not an employee, so you can't set me the salary. You can do something else with me, but you can't change my salary because I'm nobody. We have this in my Java web framework called takes. We have this authentication mechanism where we have a class which authenticates the user who actually enters the system. And to authenticate, this method returns an identity, or it returns a null identity. So it's not, there is no null actual, but there is another identity which is anonymous, which is called anonymous. So when you ask me who is entering the system, I can give you two answers. I can give you the real identity, or I can give you something which looks like real identity, but it's called anonymous. And then it's up to you. If you need to really know who enters the system, and you really need to differentiate between real users and anonymous users, then you make this decision. You compare and decide, okay, this is anonymous, this is not. But if you don't care, if you just get an anonymous identity and you just, I don't know, for example, just go continue execution and you just log the process, like, yes, this identity just got into the system and it did something. You don't need to know what the identity was. It's a real user or it's an anonymous user. You just need to log the execution and say, like, identity number 1, save the file. Identity anonymous, save another file. Identity number 5, save the file. So it's going to be just a log line, for example. You don't need to you don't care about what's inside the identity. Works perfectly fine. But if you want to go deeper and ask, for example, what's your name, then anonymous identity will throw an exception and say, no, I'm not a real one. I'm just anonymous. We don't know the name of this user. Yes, somebody entered the system, but that's an anonymous user without a name. So it's kind of, we control it. That's my point. Another question. Isn't it more adequate conceptually and maybe even easier throwing an exception in all cases? You know, sometimes in general, I would suggest to use exceptions more than null objects, definitely, of course. Like I use it in 90% of cases, maybe 95% of cases, you use exceptions, of course. You throw exception, well, in general, you throw exception as much as possible. The more you throw exceptions in your code, the better your code is, I think, in general. So the more brittle, the more fragile your code, the more frequently it says, I can't continue, there's something wrong, the better the code is. So it has to be as fragile as possible and as much as possible covered with the unit test. That's kind of a conflict of interest between two approaches, which will make the quality higher and better. So on one side, you make your code brittle and fragile and fail as soon as possible, fail fast. And on the other side, you try to cover it with unit tests as much as possible. On this combination, the quality goes up. So in generally, conceptually, I would say that in exceptions is much more preferable. But in some cases, you need to, like I just gave an example of the authentication of a user. So I'm asking you, who is the user, and give me the user, give me the identity, which is now using my system. So that would be wrong if you just throw an exception and say there is no identity. It's way more convenient to say there is an identity, but it's anonymous. So it will be like easier for me, instead of catching the exception and thinking, okay, it's now there's no exception, and then do something else. I just get an identity from you, but the way I use it, it just depends on me. In most cases, I just don't need to know the name of this user who is actually using the system. In most, like I gave an example with the logging, I just log who is using. I mean, I just log the type of the user using the system. Anonymous, not anonymous. Anonymous, not anonymous. That's it. So I would, yeah, suggest exceptions in most cases, but sometimes null objects are, conceptually better. 2 more questions and we're done. Don't you think that exceptions should be used only in exceptional cases? This is why they were created. But in the example with employee, if no employee is found, that's a normal situation, not an exceptional one. What do you think from OOP perspective? Yeah, that's a good question. That's a good one. Yes, I think that yes, definitely exceptions are for exceptional situations, and we definitely shouldn't control the flow with exceptions. So it shouldn't happen. We should not tell our users that, you know what, you call this method, and then if I give you something, use it. But I can throw this exception if something is, like, if I think something else, I can throw that exception if something else. This is not really a good approach. There has to be one exception, usually, in most cases, one exception per method, and these exceptions means that something is wrong on the application level. So it's kind of a message that the entire application has to stop, because we hit the place where something went completely wrong. That's what exceptions are for. So in this example, like I showed before with the employee, throwing an exception, when you ask me, get the employee by name, and I give it to you. If you want one specific employee, that's the design of the method. That's the signature of it. One employee, one call, you give me the name of it. So I have to return you the employee. That's my promise to you. If I want to make it, if I think that this situation, like getting an employee by name, if I have to give you the possibility to be more flexible in this and not crash the entire application when there is no employee Jeffrey, then I will give you another method, which will be called not get employee, but find employee. And then find employee will return a collection of employees found. And this collection will contain 1, 2, maybe 0 items. So you're asking me to find the employee by the name Jeffrey, and I return you the collection of found employees, and maybe it's going to be one element, and then you will see, okay, if it's empty collection, there's nothing found. Or iterator. If it's something in this iterator or collection, then something is actually found. So yes, definitely, exceptions should not be used for flow control, but they must be used for like real exceptional situations. Okay, one last question. That this webinar is about programming languages, but I wonder how you feel about null in SQL and SQL. Normalizing null out of your database can make it more complex and thus harder to maintain. That's a good question to think about. Well, I'm in general kind of think that's null. It's kind of bad idea, but in relational databases, null is part of the relational calculus, and it's not just, there's different source, there's different origin of this null in relational databases. It's not coming from like we have here, the pointers and location and memory. It's coming from inability to match two relations together. So if I select, for example, I have to this multiplication of two sets, for example, of two relations, two tables. Then if they match, if I find the match, then I put the data there. If I don't find the match, then I have to put something in there. So it's not, there's a strong science behind that. So I think in SQL, null has its perfect place because it's different thing. It's not a pointer. It's not a location memory. It's like an absence of data. An absence of data is a perfectly valid situation in relational calculus. So it's different things. In programming languages, it's null means the zero basically. It's a zero instead of a real pointer to memory. That's what it's coming from. And this is the very old and long time ago expired idea. But in a relational database, it's a perfect absence of data because they have the same names, null here and null there, but they mean completely different things. That's what I think. Okay, guys, we're done. It's 1 hour. Thank you for attending. See you next month. It's the first Wednesday of every month at 11 p.m. Pacific time. Thank you very much. Happy coding.